Hello and welcome to AI for Developers. I'm Chaitanya Talking Bot. Today's lesson is titled Knowledge Graph Embeddings, representing knowledge as vectors. Imagine a giant web connecting everything you know. That's a knowledge graph. It's like a giant family tree. But instead of people, it's concepts, things, and their relationships. For example, Barack Obama is related to President of the USA, Democrat, Illinois, etc. We can represent this in a database using nodes, things, and edges, relationships. Computers understand numbers better than words or concepts. We can represent everything in the knowledge graph as a vector, a list of numbers. Think of it like a secret code that describes each node. E.g., Barack Obama becomes 0.1, 0.8, 0.3, 0.9. The closer the vectors are, the more related the concepts are in the knowledge graph. We use special algorithms, like Word2Vec or Node2Vec. We'll cover some of the popular ones, to turn nodes and edges into these vector representations. These algorithms analyze the relationships in the graph and assign similar vectors to similar concepts. It's like magic, but it's really sophisticated math. How do we know if two vectors are close? We use a simple math function called cosine similarity. Don't worry about the specifics now. Just understand it measures how much they point in the same direction. High similarity implies high relatedness in the knowledge graph. Let's say we have the vector for apple, the fruit. By finding vectors with high cosine similarity to apple, we can discover related concepts like fruit, red, tree, healthy snack, etc., all automatically. This is how AI makes connections. This technique is used everywhere. Think recommendation systems, suggesting movies or products, question answering systems, finding answers in a large database, and even building more intelligent chatbots. This is how AI can understand the context and relationships between things. We'll demonstrate a simple example using a popular Python library. You'll see how easy it is to create embeddings and calculate similarity scores, even with no prior AI experience. This will give you a hands-on feeling of how this works. We've only scratched the surface. There are many advanced techniques and libraries, and we'll explore further in upcoming lessons. But now you have a solid foundation to understand this powerful AI technique. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.